Hey guys, we're going to look at this equation here. 12y minus 15x equals 84. Now what they're wanting us to do is put the following equation of a line into slope-intercept form. If we remember, slope-intercept form is y equals mx plus b. Now, all that we're doing here, we have a y, we have an x, up here we have a y, we have an x. Our slope-intercept form is solved for y. So all we need to do with this equation is solve for y. So first thing I want to do is get rid of this 15x off the left. So I'm just going to add 15x to both sides, like so. And I'll be left with 12y equals 84 plus 15x. Right? Negative 15 and positive 15 cancel out. Now I need to get rid of the 12, so I'll divide both sides by 12. So I've got y equals 84 plus 15x over 12. Let me clean that up just a hair. Over 12. Now, we got to remember a rule about fractions here. When you have two fractions that are added together, if they share the same denominator, you can add the numerator. So we're going to expand this statement. Y equals 84 over 12 plus 15x over 12. All right. Now we can simplify these fractions. Well, let's come to our calculator, and we can see we've already done that, right? I typed in 84 divided by 12 equals 7. So let's do that real quick. 84 divided by 12 equals 7. So this is going to be y equals 7 plus, and here I got the fraction of 15 twelfths. So I'll type in 15 divided by 12. I get 5/4. So this is going to be 5/4 x. The x here I just bring out to the side. Now, if I want to keep this in the same standard notation of the slope-intercept form, all I have to do is switch these two terms. This could be y equals 5/4 x plus 7. And there we have it in slope-intercept form. Now, we can use our calculator to help us with this. However, this is a little tricky. But what we can do is go to the equation and add a equation in the standard form here. And so we're going to look at x plus y equals 0. Now, our x here is negative 15. And we have a positive 12 for our y. And this equals 84. So I'll put that in there. Negative 15x plus 12y equals 84. I'll say OK. Now, if I go to solve the equation here, we're going to see that it's solved for x. It says x equals 4t minus 28 over 5. Okay, now t here, you're wondering where t came from. Well, it's calling y t. It says y equals t. So where it says t here, we need to think y. Now, we don't need to solve for x. We need to solve for y because we're putting it into slope-intercept form. So what we have to do here is go back, and we have to trick the calculator. We're going to switch the x and y because every time we run this, it's going to solve for x. But since we don't want it to solve for x and we want it to solve for y, we're going to switch our x and y so that it will solve for the variable we want it to, even though we're calling it something else. So come down here and go to solve the equation. Now we have solved for x again. The calculator is solved for x, but we know that that x is actually our y. So remember, our x is y, And it says y here. It says that y is t, and we need to know that that is x, right? Because we switched our x and y. So when we read this, we will actually read y equals 5x plus 28 over 4. Okay? So that's a little bit of a mental flip-flop there, but the calculator has done the majority of the work for us. Now, let's think back here. This is very similar to what we had right here. And remember, we broke our fraction apart and then simplified. So let's go ahead and do that. We got y equals 5/4. So 5/4, and I'll bring my x out to the side. 5/4 x. What you notice right here, we had 5/4 x plus 28 over 4. Well, if we go back to our calculation and we do 28 divided by 4, what do we get? Well, we get 7, which is expected right there. 7 is our answer. And notice that now we have the same answer as before, but with a lot less writing. So if you can use the calculator, that's great. But if that mental switch of moving the variables around and remembering all that is too much, just solve it the normal way.